So my name's Anita Nikolich. I'm a computer science here. They squeezed me in with a 15-minute talk, so I'm going to talk really fast, faster than I normally do. So I'm going to talk about something called Fabric. It's a brand new NSF grant that we got 2 weeks ago. I'm the co-PI on it and the co-director. It's a $20 million grant. So this is a team. It's led out of University of North Carolina, a research institute called RTC. IIT is a co-director. We got a bunch of people, including the Department of Energy, and I'm going to tell you why that's really important. So we're leveraging Department of Energy fiber, which goes across the U.S., Kentucky, Clemson, and a bunch of other places. So what's Fabric? What is it? Why do we need it? So if anybody here is an academic researcher, you've probably written a paper that said something like, the internet is showing its age. And you probably have written that like many, many times. If you're like me, I'm a network operator. You've shaken your fist about how BGP stinks and it needs to be replaced. And probably not during my lifetime will it be replaced. But really the mantra is the internet's showing its age. And applications were designed just differently 40 years ago. But what's changed now? Why do we need a place to test at scale? Compute is cheap, storage is cheap. We can put it directly in the network, and we can do better programmability. If anybody here plays with OpenFlow or SDN or P4, these things are getting easier to put both at the core and the edge to enable programmability. A lot of advances in machine learning and AI, and of course with 5G and IoT and different kind of cloud technologies, you wanted an integrated platform, a computer science test bed to try to test all these. The problem is when you're trying to do 5G slicing, you're trying to test a new protocol at scale, maybe something like NDN that's going to replace TCP/IP potentially. That's not a great place to do it at scale that's not IP based. So you're always hamstrung by the equipment that's there. This is an opportunity for the community, and by that we mean both academic, the industry, government, the community, the network community, the security community, to push the boundaries, to get more control over the data plane, more control over the network, use it as perhaps a big data instrument, and design new protocols. The key being, and I'm a security person, having security built into it. So we have 4 main use cases. The 5th bullet that you see is really to help the next generation. So we're going to have high schoolers and college students help us build this platform. Much of the grant is intended to be used the first 2 years to literally build this out. But our 4 use cases are for a new internet, design new internet protocols, security, integrating HPC wireless and IoT to have this diverse environment. One of our drivers I'll talk about is actually first responders. So they can do more processing at the edge, not have to backhaul, during a hurricane, all that information back to a data center. And to be able to integrate machine learning and AI, there's like this dream of making self-driving networks. And if you run a network, the last thing it does is self-drive. But it would be nice to get more intelligent information across the WAN from the network itself. So this is the core. A lot of these points you see, we are leveraging. The yellow is our supercore. It's a terabit supercore. So what we're doing is leveraging Department of Energy. They are rebuilding their network, which is a science network, to build, to bring back physics traffic and genomics traffic. We're using their optical links. We're getting dark fiber. We're leveraging that. We're leveraging some of their data centers, some industry provider data centers, to put in these cores and edge devices. Part of what we're looking for, and my plea to you is, we've talked to industry folks who are willing to give us, a couple of rack units of space to put a node. That would be immensely helpful so we can grow this footprint. So this is currently where we have equipment. These are a bunch of universities and regional data centers. So what is a Fabric node? So we have this really beefy terabit core, which is programmable. Then we have a bunch of core and edge nodes. All the core and edge nodes have GPUs, they have compute, storage, and programmable network capability. So really beefy GPUs. You can use, if you want to program using P4, OpenFlow, processing speeds up to, I think we're doing up to 4 times 100 gigabit speeds. And the key is people can access the hardware directly. You can get to bare metal directly. You can bring your own equipment. You can use our metronome cards. You can use GPUs to really do the experiments you need. The testbed will connect with cloud testbeds. It connects with things like Google and Azure. It connects to supercomputing centers to really make a huge plane where people can, on bare metal, wherever they need to experiment, they can do it. You can see the cores are mostly at kind of like Equinix type facilities, and the edge nodes are primarily at campuses or labs. So one of the things that's near and dear to my heart, I'm a measurement person, is to do better measurement. And I feel like this is where we could use input over the next 2 years. Of course, there'll be the traditional measurements that network people want. We have something called packet GPS, where in theory, at any point in time, you should be able to see during an experiment where your packet is, micro level, microsecond level measurements. We'd like to get to picosecond measurements. We're not sure people want that, but really figuring out how to do time synchronization across this humongous platform is really challenging, and it's really expensive. So any ideas about measurement or what people kind of real operators need for measurement is very helpful. The optical ones are fairly easy. Other types of measurements, we're still kind of wrestling with what's the right thing that we think people want. So real briefly, I won't go through all this, but what Fabric is and what it isn't. What it is not is it's not intended to be a brand new way to send your packets. It's not intended to be operations or real world processing. It's not intended to be long-term production. It's not intended to, if 5G dynamic slicing for first responders come through, it's not intended to support first responders. What it is intended to do is experimentation that says, you know what, we've validated that this is the right thing to do during a crisis, and we've tested it in all sorts of connectivity and locations. Now that it's ready for production, I'm done using Fabric. But the intent is really to have an everywhere programmable network. So there's not like this dumb core smart edge or vice versa. Everything is programmable. And we intend it to be extensible, to connect to a bunch of facilities, and everybody should be able to use it. So it's going to be very easy to get an allocation. It's a little bit similar. Many of the folks came from the Genie environment. If anybody was an experimenter on Genie, I was not, but many people were. And we're kind of taking the best of that and ditching the worst of it. Some of the science design drivers, one of them is first responders. That's at Georgia Tech. They do a lot with first responders down there. We're doing some machine learning in the network. It's definitely not our best, most fleshed out case, but we're trying to do malware detection, anomaly detection on the WAN using machine learning at scale, which is pretty challenging. Named data networking, which some people believe is the future after TCP/IP, and of course security. So the construction timeline, the majority of the funds are for construction. So basically the first 2 years are really running the fiber, putting equipment in, making sure it works, getting authentication down, with our intent to start kind of late in year 2, early in year 3 to get people on board this testbed. So this is something where we want to get feedback early. We're doing a community workshop in the spring to make sure that our vision and our progress is appropriate. And for way off base, it's a good time for people to say, that's not the kind of measurement we need or want, but we need more of this. We're looking for a really vibrant community, facility partners, people who are willing to host equipment, people who are interested in experimentation that we might not have thought of, regional providers, network providers, government agencies, industry. So if people are interested, this would be very helpful to keep in touch with us. I'll show you our webpage. It's easy, whatisfabric.net. We have all sorts of things about where we're giving talks. There's a Slack channel. You can volunteer to put a Hank, which is not a great name. I guess it's like if you sew, I guess you'd be familiar with the term Hank. But that's a node. If you want to host a node, even better. Or if you want to talk about your research. So that's my very quick presentation. Come talk to me during this conference. We would love to involve more people in this.
And we have 5 minutes for questions and comments.
Sure.
How do we get involved?
If you go to, there's a couple things. One is a very light mailing list. So we have a Twitter feed. We have a mailing list here that will you can say if you're an experimenter, if you're an academic, if you're industry. It's kind of a light mailing list. There's a lot of information on that page. You can give us feedback. We can come talk to you. We have a whole team, an outreach team that I'm part of, where literally that's what we do is just get in calls with people and get feedback. And if you want to be an experimenter, we put you on the list. So what we do is you set up a call with us right now because it's early days. We make sure that we are satisfying what you need for experimentation. And then early in year 2, which would be next September, you'd be available to come on the platform. So you could get an allocation. You just say, I need about this much GPUs. I need this. You may not know what you need, but sign up there, and you'll be in our mailing list, and we'll have your name, your organization, your area of research would be really helpful, and that's how we'll get in touch with you.
On the graph that you had the orange, you had Chicago connected, and
Chicago is
I saw
connected.
Illinois, Champaign. You had Chicago connected to. Is it connected to? Is that Chicago? Yeah.
So Chicago's our connections at Starlight, which is a big telco hotel downtown. It's hosted by Northwestern. It's an old Ameritech facility.
Oh,
so
yeah,
Starlight's a
Starlight.
big
Okay,
international
okay.
facility. And then NCSA has a node just because they're NCSA.
Okay. So you have any universities connected there? Because we brought Internet 2 over to 350 Cermak, the world's largest data center over there. So on the Internet 2 side, so you have any universities connected from Starlight back?
So Starlight is the Chicago connection. What we are now working on is getting universities. So universities can connect a couple ways. They can go through commercial internet. They can go through Internet 2. So like here, if you're on campus, you would use your Internet 2 connection, which would physically go up to 350 Cermak and then go to Starlight.
Okay, so we can connect you through Starlight. So are you trying to run some dark fiber now? You saying in town or to other research facilities? Or?
So Chicago is a really rich dark fiber footprint. What we would like to do is put more nodes within Chicago, so ideally on campuses. So right now, our major core is in Starlight downtown. Ideally, because there is so much dark fiber in Chicago, and we have a node down at U of I, we'd like to have one at IIT, we'd like to have one at Northwestern, whoever wants to, definitely, Wisconsin, the Midwest area. So if they would host a node, certainly if they have Internet 2, who is a partner of ours, and they're providing bandwidth for this, they can just get to the instrument through Internet 2.
Well, that's great because I've got dark fiber coming right in front of this place. It's not connected though. It has to go to 350 though. But yeah, we can do a node here.
We should talk then.
Yeah.